Okay, not sure why that's not working, but it's okay. Okay, so as promised, here's a quick video on esters and the esterification process. As I said before, if you are a betting person, there's a very good chance that you will need to describe and draw the reaction that makes an ester, the esterification reaction. So, just a little bit of review before we start, because we need to know how to name these things and draw them. So if we have this picture here, what is this? Well, the first thing is we need to look at it. Okay, it's all single bonds and single carbon, so the root is going to be methane. But then we look over here and we see we have a functional group, an attached alcohol, OH. So we know this is methanol. Okay, and we're correct. This one, we've got two attached carbons, so the root word is F. And we've got an attached alcohol, ethanol. Okay, we don't need to say where the alcohol group goes because on either side it's still going to be attached to the first carbon. Propanol, three carbons, prop. And the OH is attached to the first carbon. It could be propantuol if it was attached here. If it's attached here, it's still propanol as well. Okay? But you need to be able to identify alcohols for esterification reactions. The second thing you need to be able to identify is an organic acid. Okay? So here we know it's an organic acid because we've got the double bonded oxygen, and so we've got it's called a carbonyl group and a hydroxyl group. They're bonded together. Okay, it's a carboxylic acid, so we put the word acid on the end. So this is meth, the root word for one carbon. So this becomes methanoic acid. Two carbons, this becomes methanoic acid. Three carbons, propanoic acid. Four carbons, butanoic acid. Okay. So, our esterification reaction, which again, please study because I think you're going to see one on your final exam, is the combination between an organic acid and an alcohol. Okay? These things occur a lot in nature, not just some weird thing that you find in a chemistry textbook in a class. They occur a lot in nature. They make a lot of the smells that we have. So what makes an apple smell like an apple? It's an ester. What makes a grape smell like a grape? Well, that smell is actually an ester. It's an organic molecule that's an ester. Okay? So here, if we're to make an ester, so here we've got 1, 2, 3 carbons, and then we've got the carboxyl group on the end. So this is propanoic acid. We're going to combine it with methanol, OH. Okay? So what happens in this esterification reaction? Well, the hydroxyl group from the acid comes off. The hydrogen of the alcohol comes off, and we've got two H's and an O. Of course, you've known that since elementary school, I'm sure. H2O, water, comes off. And then it forms a new bond between the oxygen of the alcohol and this at the end here, this carbonyl, carbon at the end needs another bond so it can have its complete octet. Okay? So the only tricky thing is really naming these things. So you have to identify the alcohol group. This is the alcohol group. Okay, it's going to be usually the smaller group. It goes out first, one carbon, so it's methyl, and then this was propanoic acid, so we just change it for the ester O8 on the end, so this becomes methyl propanoate. Okay. Okay, this is just showing the bonds that were broken there before. This whole bond gets broken, that gets broken too. Okay. Again, you've already had practice with this, but you need to practice, practice, practice. So if you were to do this on your sheet, you have to draw a couple esters, and we'll go through that, but just serves as a nice kind of introduction to esters. So if you have ethanol and you're going to combine it with propanoic acid, the alcohol group goes first, so it becomes ethyl. Drop the OL part off because it's not an alcohol anymore, it's an ester. It becomes ethyl propanoate. What do you think about this one? This is butanol, right? Butanol for 4 carbons. If we drop the OL part off at the end, it's going to become butyl methanoate for the methanoic acid. That's an acid with only 1 carbon. So butyl methanoate. This one pentanol. This will become pentyl, and this will become ethanoate. Okay, butyl methanoate, yes, and pentyl ethanoate, yes. Good. Okay. I hope we have time to do this, but if not, you should just know briefly this sort of laboratory procedure. So you mix your alcohol with your acid group, your organic acid. So in this case, we're mixing some pentanol, or just pentanol. You don't really need to indicate the 1. You can if you want. And what's called glacial ethanoic acid. So glacial in chemistry means the same thing as, I believe it means the same thing as anhydrous, which means there is no water. So any water has been removed from the solution is what that means. So glacial and anhydrous or anhydride is the same sort of thing. I'm pretty sure. Okay. With these kind of reactions, so you have to mix them together, but remember, anything to react together needs a certain amount of energy for particles to collide, right? If you were just to put these two together, it would be an extremely slow reaction. So we do a few things to speed the reaction up. Number one, if you want to speed something up, we always add heat. Remember our kinetic molecular theory, you want the molecules to move faster so they can have more collisions, add energy to it in the form of heat. That'll do it. The other thing with a lot of these reactions is to speed up as well, a catalyst is used as well. And a lot of these for making esters, the catalyst is a form of regular inorganic acid using sulfuric acid. We're not talking about a weak one like we'd usually use. It has to be a very strong concentrated sulfuric acid. For reasons I'm not exactly sure, but I'm sure if we have the time, we could look that up. Okay, so I hope we get to make a few esters in the lab because they're the basis of perfumes and smells in nature, and you can smell, wow, mixing these two things together smells like apples or mint. So it's really interesting. But it is a little bit hazardous because of the concentrated sulfuric acid. On your exam, you could be asked briefly to prepare a procedure for making an ester. And this is what you could talk about: mixing an alcohol with some form of mixing alcohol with some organic acid in the presence of heat and a catalyst. I'm not going to talk about that. Okay, practice that up, and then I'll show you some examples on our sheet.